So, in the world of Fusion 360 and 3D printing, there is a conundrum about thread sizes, which has in the past been driving me around the bend. And it's all come to head because I was trying to get a thread for one of these, or the holder for one of these working. This is an Aperture B7C, so let's just switch that off. When you print very small threads, and when I say very small, I mean kind of up to M5, like on the front panel of this, or like on this, everything fits perfectly. You just come along with your hex screw or whatever it is, you screw it in, it's okay. But what I've been noticing is that the bigger you make the screw, the tighter it gets. And I did this test piece here, which, you know, you'll see is running beautifully at the moment. And when I initially did it, these two parts just would not fit together. Now, the reason they work so well at the moment is because I took a metal tap and die set and put the tap through that and the die around this, and this has made an incredibly smooth running component. But this is the lamp holder in question. Oh, it's quite tight. And here's kind of the conundrum. If we print a 70mm hole and a 70mm plug designed in Fusion 360, they fit together with virtually an interference fit. They're perfect. If we print a 40mm 2.5 threaded hole, we take our light holder and it will not go in. If we expand the size of the hole in the X and the Y directions by 3%, it does go in. But if we've got a component such as we've got here, if you expanded this whole component in the X and Y directions by 3%, the next components up, this lot, they're not going to fit. So what's the solution? This is what I've found. If you are going to work on something like this, the first thing you need to do is to model this component here. So you just make a cylinder that's 40 diameter and reasonably long, and then you cut the thread into that, or you just select the area, model the thread onto that. Then you multiply that component in the X and the Y direction by 3%. Then you model your body component, which we've got here. Then you subtract the male thread from the body component, and then you've got something that fits, and all of the other components on top of it can fit as well. Anyway, if you do that, you can then go on and make some kind of useful bits and pieces like this. And I've just been reflecting on this, and this principle, or this conundrum of the bigger you get with the threads, the further they are out. I kind of discovered it last year and didn't realise what I was seeing when I had to make a part for our gardener's tractor, which was a 100mm 4mm pitch thread. And I remember measuring this thing up many times with this and thinking that the manufacturer would use a non-standard thread, and I realised that the way I got around it was multiply it in the slicer by 3% and got around the problem there. But now I've gone through and thought through everything that's going on, I've realised that the conundrum is directly in the way that the modelled thread gets translated into the mesh and then sliced and printed. So the principle of designing the thread, multiplying it by 3% in X and Y, and then subtracting it from the body that you want to go into is working perfectly. So there you are, and there it was. Thank you very much.